we're going to review. So what I've put up here is one of each type of problem, so go ahead and solve each one. So the first one's addition, subtraction, so you need your common denominator. Next one's multiplication, so you just simplify it and cancel. Next one is division, so change it to multiplication, flip it, and cancel. So go ahead and do that. Okay. All right, so let's check these, or let's go over these. So again, addition, subtraction, you have to have common denominator. That's the main thing to remember. And this one factors to x, minus 2, and my board's messed up again, x minus 1. Was it this class that it did so bad?
Yeah.
It got better, and now it's worse again. But not as bad. Okay, so when I factor this, I get x minus 2, x minus 1. This is just x minus 1, so my common denominator is going to be x minus 1, x minus 2, right? Okay. So this first fraction has an x minus 1, so to make it have the common denominator, I have to multiply by x minus 2. You have to distribute, so I get x squared minus 2x. Okay? The next one is already has a common denominator, so I just bring that over. So now, again, at this point, you don't want to simplify because, yeah, there's a lot of common factors because you just multiplied those common factors in, right, while you were trying to make a common denominator. So once you build your two fractions, now it's the time to just perform the addition or subtraction. So in this case, when we add, we still have our denominator. So x squared combines with nothing, so we get x squared. Negative 2x plus 2x cancels out. Then we get a negative 1. So this is our first answer, right? But now we look at it, and now we can look, now that we've done the addition, now we can see if we can simplify, right? And this does factor x minus 1, x plus 1. So now those cancel, and our final answer in its simplest form is this. Okay? Make sense? Kind of? Okay. All right. The next one, multiplying. Again, on this one, we don't need a common denominator, right? You just factor it all, and anything up top cancels out with anything on the bottom, right? So factoring this, x minus 2, x plus 2. That doesn't factor. X squared minus 1, x minus 1, x plus 1. This one, how do we factor this? What can we do? Take out an x, right? GCF. Okay. Now we just cross out again. Anything on top, anything on the bottom. So x plus 2, x plus 2. Is that it? Oh, thank you. X plus 1, x plus 1. So now, that's it. So now, as our answer, we just take anything left. So up top, we just had x minus 2 left. And on the bottom, we have x times x minus 1. Okay? Make sense? All right. Now, last was division. And remember, division is just changing to multiplication, flipping it, right? So what I'm going to do down here is just write the factor form in the right order. So how does the top factor to what? Multiplies to 6, adds to negative 5. What do we get? Right, x minus 2, x minus 3, over x to the third. Change it to multiplication. Now I'm going to flip this second one, so I'm going to go ahead and put 4x squared on top because I can't do anything with it. What multiplies to negative 10 adds to 3 plus 5 minus 2. Thank you. Okay, so now it becomes just a multiplication problem, right? So I cancel anything on top with anything on the bottom. So I can't cancel any more factors. What can I do with the 4x squared and the x to the third? Because they're just talking. So how can I cancel those? Right, so the 4x So I've got 2 x's on top, 3 on the bottom. So those 2 basically cancel out 2 on the bottom. So my final answer is x minus 3 over, 4, sorry. 4x minus 3 over x plus 5. Okay, questions about that? Does that make sense? Does it kind of come together a little bit more now about just the difference? And the thing is on this, you just have to like memorize it. You know, you just have to understand what each operation means. Okay? All right. You have some holes in here? Okay, so next. Okay, so today we're going to do similar stuff, but a little bit different. We're going to deal with complex fractions, which seems like all fractions are complex in a way. But first of all, so what we're going to do today is complex fractions as equations, but first we're going to practice them with numbers, okay? So I want you guys, actually let's just talk through these, okay, because I tried it on their own last time and it didn't really go really well. So let's try them together. Okay, so first thing about complex fraction is always, they look intimidating, right, but they're really just a fraction over a fraction. And we've seen these before, so it's like it's 2/3 divided by 1/9. So we do what? What's that? No, we don't need common denominators. We're dividing. What do we think, Madison?
Keep, change, flip.
Right. Keep, change, flip, or don't no touchy, flippy, switchy. So which sounds kind of weird, but that's what a student told me years ago. So you got 2/3 stays, right? You change it to multiplication and flip the second one, right? So it becomes 2/3 times 9/1. And then what can we do right here before we even multiply?
Get out of 39.
Right. Cancel 3, and we get 6/1. Right? Or you could have multiplied it through and you would have gotten 18/3, which also gives you 6. Okay? So the goal is always to have a fraction over a fraction, right? You cannot do this until you have made them a fraction over a fraction. So this next one, this top is not a fraction yet, right? It's actually 2 fractions. Okay? So we have to make 1 fraction. Okay, what do we have to do up to the top to simplify just the numerator? What do we need a, okay, and what would be our common denominator? Right, between 3 and 7, there's no common multiple, right? So we just multiply them together, so it's 21. So this is the way I want you to get used to the notation I'm going to use today. So rather than writing them each with the common denominator, I'm going to write just the common denominator, okay? What do I have to do to 2/3 to make it a denominator 21? Times it by 7, right? So this becomes a 14. Does that make sense? Plus 15, right? So this I have to multiply by 3. So plus 15. So my numerator, the top, becomes 29/21, right? Divided by 5. If I want to make 5 a fraction, what do I do? 5/1. So now I can, what's it called? Keep, change, flip. So I keep this, I change it to multiplication, and I flip it. And I multiply across. Here, I really would look to see if I can simplify, but I can't, so it becomes 29/105. Okay? Everybody good with that? Okay? Now, let's try another one. Okay, so again, we need, our goal here is fraction over fraction. This is not a fraction yet, right? It is it's a fraction problem. So I need to make it a fraction. So what's my denominator at the top going to be? 3, right? This is I can't curse on a recording. So this is like 1 over 1, right? And 1 over 3. So my common denominator is going to be 3. So what do I have to do to this to make it a 3, the 1? Multiply by 3. So this becomes 3, right? Minus 1, which gives me 2/3. Over, what's my common denominator going to be down here? A 5. So what do I have to do to the 2 to make it over 5? Multiply it. So I get 10 minus 3. So I get 2/3 over 7/5. Right? And then I can keep, change, flip, I like that. And multiply. So I can't really reduce 2/3 and 5/7 right now. So I multiply, I get 10. 20.
You always multiply, like it goes from, like you multiply it.
Yes, you always, the goal on all of this, even what we're going to do next, is you get it to be a fraction over a fraction, and then multiply by the reciprocal. Okay? Very good. All right, so now it's just going to get a little more complicated because we're going to introduce variables into all of it. Yay! So again, but the thing about this and the thing about this section being difficult is what you want to do is just keep these rules in your head. So keep the rules in your head that the goal that we're trying to do is 1 fraction over 1 fraction. Okay, and I just kind of made that up last class to help us. Just remember that that's all you want to do. 1 fraction over 1 fraction. Once you have that, you just set up the multiplication. Okay? So we'll look over these steps here. So first, we need to find the common denominator in the top and bottom if needed. So if we don't already have a fraction over a fraction, we have to combine them, and you'll see what I mean. I get the common denominator. Then we multiply by the reciprocal and simplify. Okay? So this first one is a fraction over a fraction, right? Even though there's variables, it's just 1 fraction over 1 fraction. So we keep, we change to multiplication, and we flip the bottom. Then we multiply across, so we get 2y over 3x. Okay, very good with that one? All right. Now, get a little bit more difficult. Now, 2 over x plus y, is this a fraction? Yes, because again, think about that as a little family. This is not 2x plus 2y or anything like that. It is just 2 over x plus y. So it is already a fraction. Is this a fraction? It's not, but what can we do to make it a fraction? 5 over 1, right? So we can make it a fraction. So now we have a fraction over a fraction, keep, change multiplication, flip, and multiply. So multiply the top, we get 2, the bottom, 5, x plus y. And now you could distribute that 5 if you want to, but since we're trying to get it in simplest form, if you keep it like this, you can tell it's in simplest form. You know, if you keep it factored, it's easy to look at and see, you know, that it's nothing else can cancel. But I wouldn't take off if you, God bless you, if you distribute that. Okay? All right. Now, when we look at the next one, the top's a fraction, right? But the bottom is not a fraction because it's 1 plus x over y. Everybody see that? All right. So we keep the top. We make the bottom a fraction. What is our common denominator going to be? Y. So how do I make 1 something over y? Multiply it by y, right? So this becomes a y. And then plus, and then x over y already has our denominator that we need, so we make it, we just bring it over. Make sense? So now we have a fraction over a fraction. So we keep the top, switch it to multiplication, and flip. And now we multiply. So 3 times y is 3y over 2 times y plus x. And again, this y is part of the family. This y is just talking, so we cannot flip them. You cannot, I won't keep saying that, but anyway, we cannot cancel. Okay? Question about that? Not too bad? All right. Let's try another. Okay. Okay, so we have the top and the bottom. Is the top a fraction? No, but the bottom is, right? So the top, what is our common denominator? We've got 2 over x plus 3 over y. So what's our denominator going to be? xy, right? X times y. So if we need to make 2 over x have a denominator of xy, what do we do? Times by y. So this becomes 2y plus 3x, right? It comes by x. And then over 1 over xy. So now we have a fraction over a fraction. So we keep this one, change it to multiplication, and flip this one. So we get, so now this becomes xy over 1. And now what can we do before we multiply? Right, cancel out x and y. So we end up with just 2y plus 3x. Okay? Okay, everybody good? You want to try the next one on your own? Okay, go and try that one.
I'm gonna try it.
Okay, so, all right, so if we look at this one, we want to get fraction over a fraction. So on top, our common denominator is xy. So to make this have that denominator, we're multiplying by y. To make this one, x over y, have that denominator, we're multiplying by x, right? So we get plus x squared. One thing you guys want to get in the habit of now is when you have created something like that, put parentheses around it, because now it's a family, it can't be broken up, okay? Now, over common denominator down here is going to be y. So we bring over our 1 to make 1 over 1 have a y denominator. We multiply it by y. So now this is a family, cannot be broken up. Okay? So now we take the top, keep it, change it to multiplication, flip the bottom, and again, rewrite those parentheses. Okay? So now we can, so we've got y plus x squared over xy times y over 1 plus y. So these guys are not part of the family. They can cancel, but nothing else can cancel. Okay, because everything else has a plus or minus with it, or this x just doesn't have anything left. So our final answer is y plus x squared, and again, use parentheses, over x times 1 plus y. Okay? Make sense? Kind of? Okay? Okay, go ahead and try the next one too. Okay. All right, girls, be quiet. Okay, so again, the top does not. We can make it a fraction. It wasn't yet, but we can. So the bottom, we need to make a one fraction, so our common denominator will be xy. So to make 1 over x have that denominator, we multiply by y. To make 1 over y have that, we multiply by x. So again, go ahead and put parentheses around that when you do that. Okay, so now it's a family. So now we keep the top, we change it to multiplication, and we flip the bottom. So the xy comes up to the top. Okay. The xy comes up to the top. The y plus x goes to the bottom. So now, even though we thought those x's might cancel, they're on the same level now, so they don't cancel. So we just multiply across. So x times xy gives us x squared y. And then on the bottom, we just have the family of y plus x, so nothing cancels. So that's our final answer. Questions about that? Madison, did you get that?
Yeah.
Okay. All right, so for practice, we're going to look at our worksheet.